So let's continue looking at the definition of logs. Remember from the last lesson we defined log of x to the base 10 equals a means that when 10 is raised to the power of a we get an x. So a is the exponent to which 10 should be raised so that we end up getting x. So log of x to the base 10 is the value by which should be used as the power of 10 in order to obtain x. That's just the definition of logs. Keep that in mind. And then we had also talked about the fact that if f of x is equal to 10 to the x, f inverse of x is equal to log to the base 10 of x. And we had seen in this picture here where f of x and f inverse of x are represented as logic machines, that when we input 3 into f of x we get 1000, and when we take that output from the f of x and input it into the f inverse of x we get back a 3, the original input into the f of x function. And this is what inverse functions do. They revert the output of f of x and match it back to the input into the f of x. Okay, now one more thing that we do when we take inverse functions, if you remember the process, the step-by-step process for inverting f of x. So let's go through that process and see what happens. It should yield the same result here, that if we follow the steps to invert f of x equals 10 to the x, we should find that f inverse of x is equal to log of x to the base 10. So let's follow our steps. So the first thing we do is we write this expression f of x equals 10 to the x as y equals 10 to the x, and then we wherever we see a y, we make that an x. Wherever we see an x, we make that a y. And so we've got, when we finish that step, we've got x equals 10 to the y. And now we make y the subject of this equation. Well, note here, this x equals 10 to the y, this expression right here, it looks very much like this expression. The 10 to the power of a is equal to x. Instead of a, you have a y here. Now, by definition, this exponent a is equal to the log of x to the base 10. So, if we just apply the definition of logs, we will see that y is equal to log of x to the base 10. Another way to think about it is y is the power by which we must raise 10 in order to get x. Just like here, a is the power by which we must raise 10 in order to get x. So we see that when we take our algebraic steps for figuring out what is the inverse of f of x equals 10 to the x, the result that we get is what we would expect. The inverse is equal to log of x to the base 10. So that sort of completes the definition of logs. Let's do some practice. So what is log of 10,000? Well, remember the definition. The definition is if you've got log of x to the base 10 equals a, that means a is the exponent or the power by which 10 must be raised in order to get x. Now, in case of this first question, what is log of 10,000, we have not specified a base. So the thing to remember is if a base is not specified, you assume that the base is 10. So we should read this as log of 10,000 to base 10. And in order to figure out what that is equal to, we need to consider what power must 10 be raised to in order to get 10,000. Well, 10 must be raised to the power of 4 in order to get 10,000. So log of 10,000 to the base 10 is equal to 4. When we come back, we'll do a few more practice problems.